Good morning. Sonny Nyeko is my name. I hope you received yesterday's recording on our first topic, data management. Today, we shall look at telecommunications and networks as our second topic. This is ICT 2 for BBA 2. Our learning objectives are as follows: to understand the concept of network and its parameters, to understand the basic components, functions, channels, and types of telecommunication networks used in business today, to identify the major developments and trends in the telecommunication technologies, to explain the modes of communication in a network, to describe the business value of the internet, intranet, and the extranet applications, to explain the digital and analog signals and the various transmission media and technologies. Last but not least, to understand the internet applications. We should also be able to understand and define the different types of, identify the different types of networks, explain the different components of the networks, discuss the advantages and disadvantages of using networks, describe the network design parameters as we had looked earlier, and last but not least, explain the different network technologies. What is telecommunications? Telecommunications is defined as a long-distance communication using electromagnetic methods. Now, communication is the transmission of signals by way of medium from a sender to a receiver. Now, by telecommunications, we know that it's the electronic transmission of signals for communications, including such means such as telephone, radio, television, and computer networks. We have a number of benefits of telecommunication, which I just mentioned a few of them, but we shall look at more later. For instance, better communication, that is through the use of email, voicemail, faxes, teleconferencing services. We have greater efficiency, better access to data, among others. Data communications. It is important for us to understand this term, data communications. Now, the term data communication means communication at a distance. Communication at a distance. The word data refers to information, as you are aware, presented in whatever form agreed upon by the parties creating and using the data. Data communication refers to the sharing of a virtual message. Electronic communications like emails and instant messages, as well as phone calls, are examples of data communications. I said that examples of data communications include phone calls, emails, and instant messages, among others. We should also know what we refer to as computer communication. As we are aware, there are two types of computers can communicate in two ways, that is through telecommunications and through networks. Through telecommunication, that is, two computers establish a link through a telephone system, whereas if you are to look at it in terms of networks, then you look at computers that are linked directly by high-speed cables or wireless connections. In other words, ladies and gentlemen, in other words, we are saying that the computer communication describes a process in which two or more computers or devices transfer data, transfer instructions, and transfer information. We are saying computer communications here will describe a process in which two or more computers or devices transfer data, transfer instructions, and transfer information. The information superhighway. Information superhighway. What is an example of the information superhighway? One of the most common examples of information superhighway is the internet. Okay? Is the internet. It's the internet. Now, the fusion of computer and communication has made it possible for telephone companies to expand from traditional voice communication into new information services, such as providing transmission of news reports, television programs, among others. By information highway, superhighway, we are referring to, let us look at it in terms of telecommunication infrastructure, or a system that is used for widespread and usually rapid access to information. Look at it this way. Look at the information superhighway as a telecommunication infrastructure or a system. I mean a system that comprises of television, comprises of telephony, or computer networks, okay, that are used for widespread and usually rapid access to information. That is what an information superhighway is. Now, what is a telecommunication system? What is a telecommunication system? Now, telecommunication system means telephone equipment and transmission facilities. Can either be either alone or in combination with information systems for the electronic distribution of all forms of information that include voice, that include data, and also includes images. Now, the basic telecommunication system consists of three elements. The basic telecommunication systems consist of three elements. Now, what are these elements? A transmitter that takes information and converts it to a signal, a transmission medium that carries the signal, and the receiver that receives the signal and converts it back into usable information. Now, we have essential components of a telecommunication system. We have a number of essential components of a telecommunication system. This includes computers, terminals, communication channels, processors, the communication software, and protocols, okay? And protocols. Say computers, terminals, communication channels, processors, communication software, and protocols. What's a computer here? That device that processes data, that process data into information. Here we are saying that messages represent the actual data that is being transmitted. In the case of a telephone network, the messages would consist of audio as well as data. Now, as far as terminals are concerned, terminals support input and output, Okay? These are devices that send and receive data. Now, inputs and output devices here are also referred to as, terminals. Now, these provide the starting and the stopping points of all communications. Okay, these terminals provide the starting and stopping points of all communication. Now, a telephone is an example of a terminal. Okay, a telephone is an example of a terminal. In computer networks, ladies and gentlemen, in computer networks, these devices are commonly referred to as nodes. Okay, are referred to as nodes, and they consist of computer and peripheral devices. Computers and peripheral device. I hope you know what a peripheral device is. Telecommunication channels transmit and receive data. Some of these, I say other than terminals, we also have communication channels. These communication channels transmit and receive data. This includes various types of cables and wireless radio frequencies. The other essential component of a telecommunication system is a processor. Now, processors are devices which support functions for data transmission and reception. Examples include multiplexers, front-end processors, modems, among others. For example, in many systems, data needs to be converted from analog to digital and vice versa. Okay, and vice versa. The other essential component of a telecommunication system is communication software. These manage the various activities of a communication network, providing the intelligence that controls both input and output. Now, control software is a control software which is responsible for controlling the functionality of the activities in the different networks. We are saying that communication software can also be looked at as a software that is responsible for controlling the functionality and activities of the network. The last one is protocols. What are protocols? Protocols specify how each of the type of communication systems handle the messages. Okay? How each of the telecommunication systems handle the different messages. Okay? How they handle the different messages. Now, what are the functional components of a telecommunication system? What are the functional components of a telecommunication system? We have a number of functions of a telecommunication system. For instance, transmission, acting as an interface, routing, processing, for editorial purposes, for conversion, for control purposes, among others. What we look at when we talk about transmission. Now, transmission is the primary function of any telecommunication system. Okay? Is the primary function of any telecommunication systems. Whereas as far as the interface is concerned, the interface acts as a link between the sender and the receiver. What the interface also does is that it establishes the interface. Okay, it ensures that that interface between the sender and the receiver is effectively established. The other function is routing. Okay, routing. What happens here is that the system chooses the most efficient path to deliver your message. The root message, okay, delivering that root message along with, here we are looking at delivering that message along with the most efficient path, okay, the most efficient path. The other function is processing. Here, it performs the elementary processing of information to ensure that the right message gets to the right receiver. Okay? Ensuring that the right message gets to the right receiver. Then the other function of a telecommunication system is editorial, for editorial purposes. Okay? It performs a number of editorial tasks. Okay? It performs editorial tasks better. Editorial tasks better, and that can also include checking for transmission errors. Okay? Checking for transmission errors to ensure that these messages are sent to the right persons or to the right recipients. The other is conversion. Another function of a telecommunication system is conversion. That is converting messages from one speed to another and from one format to another. Last but not least, we have the function of control. The function of control. Here we are saying that telecommunication systems control the flow of information. For instance, by routing which receiver to receive the message, and also helps in terms of network maintenance. We have a number of properties of transmission. We have a number of properties of transmission. These properties are, in fact, there are 5 basic properties of both the physical and the wireless links. We have the type of signal communicated, that is, can either be analog or digital. The speed at which the signal is transmitted, that is how fast the data travels. The type of data movement allowed on the channel can either be one-way, two-way, taking turns, two-way simultaneously. The fourth one is the method used to transport the data. It can either be asynchronous or synchronous transmission. Then the fifth property is when you are now looking at the channels, that is a single channel and a multi-channel transmission. Let us look at the first one. Let us look at the first property. Okay, the first property. We shall look at it by looking at the types of signals. By looking at the types of signals. What is an analog signal? What's the difference between an analog signal and a digital signal? You should be able to know the difference between these two. That's the analog signal and the digital signal. An analog signal is a continuous waveform that passes through a communication medium used for voice communication. For example, analog data, a good example of analog data is the human voice. Whereas a digital signal is a discrete wave form that transmits data that is coded into discrete states as 1 bits, and that's 1 bits and 0 bits, which are represented as an on and off electrical pulse that is used for data communication. Here we are saying that a digital signal is actually a discrete rather than a continuous waveform. A digital signal is a discrete rather than a continuous waveform. That's the main difference between the two. We should also know that all digital, if you are to compare, if we are to compare analog and digital signals, it is important for us to know that all digital signals must be translated into analog signals before they can be transmitted in an analog system. Let me repeat this, that it is very, very important for us to know this, that all digital signals must be translated into an analog signals before they can be transmitted in an analog system. In other words, the device that performs this translation is called a modem. Okay? This translation is being performed by a device called a modem. The second properties of transmission is data transmission. Data can be transferred mainly in two ways in a computer: serial and parallel transmission. Okay? Serial and parallel transmission. Now, the most effective type of transmission used in general for computer communication is the serial transmission. We should note that the most effective type of transmission that is used in general for computer communication is the serial transmission. What's the serial transmission? This is where data is transmitted or transferred over a single communication path. Where data is transferred or transmitted over a single communication path. Okay? Single communication path. Now, data is normally sent down the line one at a time, and most importantly, slower but in longer distances. If you are going to look at serial transmission, then take note that it will be slower but takes longer distances. Okay? Slower but will take longer distances. Whereas with the parallel transmission, we are looking at a situation where data is transferred using several transmission paths. Okay? Using several transmission paths. That is, data is sent down the line more than one bit at the same time. More than one bit at the same time. For example, this could be in printers, processors, and also motherboards. The other transmission property is asynchronous and synchronous transmission. Asynchronous and synchronous transmission. What is asynchronous transmission? With asynchronous transmission, we are looking at a situation where data is transmitted one character at a time. Okay, one character at a time, and where each character is 5 to 8 bits in length. What we should note is that asynchronous transmission is slower, as each character has its own start and stop time. That's the reason why it is in most cases referred to as the start-stop transmission. Start-stop transmission. Whereas synchronous transmission is a mode of transmission where data is transferred in a block of bits at a go. That's without a start and stop. Important for us to know that whereas asynchronous transmission is slower, synchronous transmission is faster. Okay, it's faster as far as sharing and information to the sender and receiving, and the receiver is concerned. The fourth transmission property is directional in nature. That is transmission. We are looking at the transmission direction. It can either be a simplex transmission, half duplex transmission, or a full duplex system transmission. By simplex transmission, we mean where data can travel in only one direction at all times. Okay, for example, using a radio broadcasting and a television. Okay, the communication between the sender and the receiver occurs in only one direction. Okay, in only one direction. In other words, the sender can only send the data, and the receiver can only receive that data. The receiver cannot reply to the sender. Now, in terms of half duplex systems, okay, this is where the system allows communication in both directions. Okay, data here travels in both directions, but only one direction at a time, not simultaneously. Only one direction at a time, not simultaneously. And the example here is a radio system where you must first use the word over to indicate the end of transmission. You must have heard this from with some of the security organizations, where someone says something over. Says over, by over meaning that my communication is already done, so you want to listen from the other side as well. With full duplex systems, here the system allows communication in both directions, unlike in the half duplex, which allows this to happen simultaneously. Now, most telephone networks are full duplex, as they allow both callers to speak at the same time. Okay, they are full duplex because they allow the callers to speak at the same time. Now, the fifth property is the communication channel. The fifth property is the communication channel. Now, by communication channel here, we are referring to the medium that is used to convey information, that is from the sender or the transmitter to a receiver. Okay, from a medium used to convey information from the sender or the receiver, or the transmitter to the receiver. Now, communication channels, therefore, are those mediums through which you can send a message to its intended audience. Okay, where you can send a message to its intended audience. Now, there are two types of communication channels. That is guided, or through the use of wires, and unguided, that is wireless. Okay, two types of communication channels, and we are saying that it can either be a guided or unguided communication channel. Now, guided media is a wired communication. Okay, guided media is normally a wired communication, where it transmits data either using twisted pair cables, might also use the coaxial cable, or even or even fiber optics. I said it can either be using twisted pair cable, coaxial cables, or fiber optics. In other words, it normally requires some maintenance charges, okay? It cannot go without a cost. Whereas the unguided media is a wireless communication, okay? It's a wireless communication. Here it transmits signals by broadcasting it through the air. Unguided media transmits signals by broadcasting it through the air. Examples here include infrared, radio frequency, and the microwave. Examples here include infrared, radio frequency, and the microwave. It is important for us also to note the characteristics of communication channels. Okay, it is important for us to note the characteristics of communication channels. The main characteristics of communication channels are majorly two, but we have several others. These two are the transmission speed, which is measured in bits per second, okay, bits per second, also called the baud rate. The second characteristic is that of the bandwidth. Now, by bandwidth, we refer to the capacity of a communication channel that is measured by the difference between the highest and the lowest frequencies that can be transmitted by the channel. The bigger the bandwidth, the better the transmission, and the measure for bandwidth is called the hertz. The measure for bandwidth is called the hertz. That is H-E-R-T-R. H-E-R-T-Z. Let me repeat this, that a communication channel is characterized primarily by signaling transmission methods used. Most importantly, through the transmission speed and its bandwidth. Okay? Most importantly, through the transmission speed and bandwidth. However, it can also be characterized by the direction or directions in which the signals flow. Okay? Other than transmission speed and bandwidth, it can also be characterized by the direction in which the signals flow. It can also be characterized by its noise. It can also be characterized by its attenuation and distortion characteristics as well. Okay? The distortion characteristics. The distortion characteristics. It can also be characterized by the time delay. Okay? By the time delay imposed by the channel and the node. The time delay imposed by the channel and the nodes. But we said earlier that they are majorly two: the transmission speed and the bandwidth. Okay? The bandwidth or the bit rate capacity. Let us look at the types of communication channels. Guided, that's by using wires. The first one is twisted pair of copper wires. Okay, the twisted pair of copper wires. Here we know that the twisted pair cable is a special type of cabling that is used in the telephone communication and the Ethernet. Okay, the Ethernet network. Mainly used in the telephone communication and the Ethernet network. Now, this cable is normally made with two separate insulated copper wires. Okay, made with two separate insulated wires which are twisted together with each other, as well as run in they are also run in a parallel form. Okay, We are saying that these copper wires, there are two separate insulated copper wires which are twisted together, okay, and they run in a parallel form. That is very important. Okay, that's very, very important. Twisted pair cables are used in telephone lines to provide data and voice channels. Okay, they are applied in the provision of data and voice channels. We know, and this is very important, dear students, that it is very common to mix fiber with twisted pair in a local area networks. Why? Why is it normally common to mix a fiber with twisted pair in a LAN, in a local area network? Why? This is because twisted wires have interference that cancel properties. Okay, they have, I said, the twisted wires have interference cancelling properties that reduces the effect of electromagnetic interference on electronic signals. This is important. The reason why we have very common, why it is very common to mix fiber with twisted pair in a local area network is that twisted wires have interference cancelling properties that reduces the effect of electromagnetic interference on electronic signals. The other type of guided wire is a coaxial cables. In short, coax is a type of cable used to transmit data, the internet, video, and voice communications. The other is the fiber optic cables, as an example of guided media. We know the fiber optics as a network cable that contains strands of glass fibers inside an insulated casing. Okay, it has a network cable that contains strands of glass fibers inside an insulated casing. They are normally designed for long distance, high performance data networking and telecommunications. Now, compared to wired cables, this is important to note. Compared to wired cables, fiber optic cables provide higher bandwidth and transmit data over longer distances. Dear students, this is important to note that compared to wired cables, fiber optic cables provide higher bandwidth and transmit data over longer distances. Let us now look at wireless connections. That's wireless channels or wireless connections. Now, there is normally, can we look at the wireless connections or wireless channels? Now, wireless networks are those computer networks that are not connected by cables of any kind. Okay? They are not connected by cables of any kind. Now, the use of wireless network enables enterprises or organizations to avoid the costly process of introducing cables into buildings or as a connection between different equipment locations. The three types of wireless communications commonly used in networking are radio frequency, infrared, and microwave, as were mentioned earlier, okay, as mentioned earlier. Let us start by looking at one of the wireless connections, that is infrared. Okay, infrared. Infrared is commonly used in televisions and the VCR remote controls. Infrared or infrared light is a type of radiant energy that's invisible to human eyes, but they are invisible to human eyes, but that we can feel as heat. Invisible, but we are able to feel as heat. Infrared light is used by electrical heaters, cookers for cooking food, short-range communications like remote controls, among others. The second wireless connection here is the Bluetooth. What's the difference between Wi-Fi and the Bluetooth? What's the difference between Wi-Fi and a Bluetooth? What I can say is that both Bluetooth and Wi-Fi are used for providing wireless communication through radio signals. Can I repeat that? Both Bluetooth, the difference between a Wi-Fi and Bluetooth is that both Bluetooth and Wi-Fi are used for providing wireless communication through radio signals. Now, the most distinction between Bluetooth and Wi-Fi is that Bluetooth is actually an accustomed connect short-range device for sharing information, whereas Wi-Fi is used for providing high-speed web access or internet. Bluetooth is actually an accustomed connect short-range device for sharing information, whereas Wi-Fi is used for providing high-speed web access or internet. The third one is, is radio frequency. Radio frequency. Okay. Radio frequencies are used in standard broadcast radio and television. I mean, where there are receivers and transmitters. Also used in shortwave radio, navigation, and air traffic controls. Also used with cellular telephones, computers, and even remote controlled toys, among others. The next slide is wireless transmission media. Wireless transmission media. Here we are going to look at the broadcast radio and the cellular radio. Now, what is a broadcast radio? Now, broadcasting radio is transmission of audio, that is sound, sometimes with related metadata. Okay, with related metadata, we now know what metadata is based on the previous topic, data management. So we are saying that radio broadcasting is a transmission of audio or sound, sometimes with related metadata, by radio waves to radio receivers belonging to a public audience. Okay, these are normally distribute signals through the air over long distances, and they normally use antennas. Okay, they normally use antennas. Okay, with the cellular radio, with a popular name such as cellular mobile or mobile phone. A cellular radio is also referred to as a cellular mobile or mobile phone. Okay, or mobile phone. Now, a cellular radio is a form of broadcast radio that is used for mobile communications, such as the cellular telephones and wireless modems. Now, what's a wireless modem here? A wireless modem is a modem that bypasses the telephone system and connects directly to a wireless network. I said a wireless modem is that modem that bypasses the telephone system and connects directly to a wireless network. Microwave. A microwave is often used to communicate with the distant locations. Now, microwave radiation is commonly referred to as microwaves. I hope we now know that microwave radiation is commonly referred to as microwaves. They normally fall between the infrared radiations and the radio waves in the electronic spectrum. Now, microwaves are widely used in modern technology, for example, in point-to-point communication links. They are also used in wireless networks, microwaves radio, relay networks, satellite, and also with the medical and cancer treatment facilities. Okay. The other is the Wi-Fi. Okay, Wi-Fi as a wireless technology. Wi-Fi is short for wireless fidelity. Wi-Fi is a wireless technology that uses radio frequency to transmit data through the air. Wi-Fi is a wireless technology that is used to connect computers, to connect tablets, to connect smartphones and other devices to the internet. It's used basically for quick network access, and interconnecting to networks. Telecommunication trends. Dear students, it is important for us to understand telecommunication trends, especially telecommunication trends of the year 2021 and 2022. Okay? Telecommunication trends of the year 2021 and 2022. I would like I'm requesting you to read more about this. 1, I'm giving you the 5 trends that are shaping the telecommunication industry in 2022. Okay, 2021, 2022. I would like you to read more about 1, the 5G deployment and expansion. 5G deployment and expansion. 2, artificial intelligence and machine learning. Okay, artificial intelligence and machine learning. 3, growth in cloud platforms. Growth in cloud platforms. 4, from the Internet of Things. From the Internet of Things to the era of Internet of Everything. The Internet of Things to the era of the Internet of almost everything. Then telecommunications, we should know that telecommunications is the driver of future work. How are you going to look at telecommunication as a driver of future work in terms of the telecommunication trends? Okay, in terms of the telecommunication trends. Let us look at the business value of telecommunication networks. The business value of telecommunication networks. Today, organizations must leverage the use of telecommunication networks or the use of telecommunication networks to improve on their competitive advantage. Okay? To improve on their competitive advantage. If that can be done, then organizations will be in the position of benefiting from the use of networks through having advanced communication, through improved cross-team collaborations, through enhanced flexibility, through reducing business operational costs, through better customer service, through increased employee productivity and satisfaction, and by reaching more customers. We are saying that organizations should normally reap from using the telecommunication systems or the telecommunication networks. The advantages that an organization can reap by using the telecommunication networks is significant. Okay, is significant. We are referring to this as the values, the business values of telecommunication networks. What are these business values of the telecommunication networks? This is what we are referring to here. Okay? And we are saying that through telecommunication networks, organizations or business organizations should expect advanced communication. Okay? Advanced communication. That is facilitating the sharing of data and information electronically through wireless or wired means. Okay? Through wireless or wired means. That's the first point. Advanced communication. Okay? Advanced communication. And of course, this is supported today by the use of tablets and smartphones. Okay? The use of tablets and smartphones. Other than the first business value of telecommunications, which we said is advanced communication, the second one is that telecommunications will definitely improve cross-team collaboration. Number two, improving cross-team collaboration. Cross-team collaboration. Now, this cross-team collaboration can be improved by using mobile phones, video conferencing facilities, among others. The third one is enhanced flexibility. Enhanced flexibilities. Okay? Another value of telecommunications network is enhanced flexibility. That is, a number of people working from home has increased significantly. It has increased significantly. It has reduced the business executives' movements, thereby freeing more time to engage in productivity and thus increasing business growth. The other is reducing business operational costs. Okay, reducing business operational costs. The other value of business telecommunications networks is reducing business operational costs. Now this is done through saving office space and increased productivity across all departments. Reducing business operational costs through saving office space and increased productivity across all departments. The other value of telecommunication networks is better customer service. Better customer service. 24/7 availability of the internet. That's a very, very good example. So the 24/7 availability of the internet has delivered high quality customer service. What happens here is that teams have been able to build customer brand loyalty with better relationships with prospects, okay, with better relationship with clients, and that normally leads to increased retention, okay, leads to increased retention of customers. The other value of telecommunication network is increased employee productivity and satisfactions. Here we are saying that teams access collaboration and file sharing tools, collaboration software, and other services may result in higher job satisfaction and productivity. Okay, when a team has access to collaboration with the file sharing tools, including collaboration software, you expect higher satisfaction and productivity. The other value of telecommunication networks is that more customers can always be reached to. More customers can be reached to. Now, the advantages of telecommunication is in business goes beyond just increased productivity and the employee well-being. You should be able to look at the different internet applications like electronic commerce, email, e-conferencing, e-entertainment, e-education, among others, as provided for in the slides. We have a number of questions that you should be discussing in your different groups. Among them is you can write down this with an example of a business in a marketplace. Discuss the business value an organization can derive from the use of telecommunications infrastructure. With an example of a business in a marketplace, discuss the business value an organization can derive from the use of telecommunications infrastructure. What would require you to read in your discussion groups is networks. We'd like you to look at the different types of networks, the components of networks, advantages and disadvantages of using networks, network design parameters, and network topologies. What is a network? A network is, let me go through this quickly. A network is a collection of computers, servers, mainframes, network devices, peripherals, or other devices connected to allow data sharing. It is important for us to note that a computer network is a set of computers that share resources located on or provided by a network node. We have different types of networks that would like you to have, that would like you to research on and discuss in your discussion groups. For instance, personal area network, local area network, peer-to-peer network, client-server network, passive optical local area network, campus area network, wireless local area network, metropolitan area network, wide area network, systems area network, storage area network, virtual private network, and enterprise private network. Please read through, understand these types of networks in your discussion groups, and you should be able to know the benefits each of these networks provide. Not only benefits, but also I would like you to look at the main benefits, just only one benefit of this network, each of these networks, and the main associated problem with this network. That is important. The main benefit associated with each of this network and its associated challenges. The other is components of a network. There are 4 major components that we should be able to know: the physical connections, the network operating systems, the application components, and protocols. With physical connections, we would like you to concentrate on those hardware components. With the network operating systems, we would like you to look at the software facilities. With the application components, you focus on the connection medium. Okay, the connection medium. To note is that all data networks are comprised of these elements and cannot function without them. We are saying that all data networks, in one way or the other, must have the physical connections, the network operating software, the operating systems, the application components, and the protocols. Consider also in your discussion groups the benefits and problems associated with each of the types of networks that I mentioned earlier. As mentioned earlier, also focus on the main reason for each of those networks. We also want you to look at the different network design parameters. Okay, the network design parameters like parameters such as availability, reliability, security, response time, the throughput, robustness, and cost. Robustness and cost. Also, in your discussion, don't forget the different types of internet and the intranet and internet specifications. Focus on the intranet, the extranet, and internet. What's the difference between intranet, extranet, and internet? Okay, internet, extranet, and internet. Then network topologies. Okay, network topologies. As we conclude, you need to look at network topologies. Topologies such as the bus. First of all, what's a topology? Okay, what's a topology? A network topology normally defines the layout of a network. We know that it shows how devices on the network are interconnected, and these devices that are interconnected on the network are normally referred to as nodes. And a network has both physical and a logical topology. So what's the difference between physical topology and a logical topology? So what are these different types of network topologies? Consider the bus topology. Look at the advantages and disadvantages, the star topology, the ring topology, and we also have the mesh topology, the hybrid topology. Now, what are the considerations when choosing a topology? What are the considerations when choosing a topology? That should also be part of the areas that would require you to read, okay? The areas that will require you to read. Ensure that you also go through the components of networks, the different components of networks. Who are the clients? What's a client? What's a server? What's a network interface card? Hubs, repeaters, bridges, and routers. Please know them. The network switch, a gateway. You should be able to comprehend these components. A wireless access point. Okay, wireless access point. In conclusion, telecommunication is an important tool for businesses. It enables companies to communicate effectively with customers and deliver higher standards of customer service. A telecommunications environment provides connectivity on demand by providing communication channels for text, providing communication channels for voice, and providing telecommunication channels for video images. Ladies and gentlemen, dear students, overall, organizations must utilize the business benefit of telecommunication and networks in order to stay competitive. Thank you. We shall tolerate questions next week during our online classes. Thank you.